Hey, how's it going, everyone? Mr. Cruze here with another review for you. This time, part 2 of the second part of the Chapter 3 Trigonometry test. Alright, hopefully you found the first two videos helpful, so hopefully this one will help you understand trig just that much better. Alright, remember, if at any time you have questions, you can tweet me, email me, or post a comment on this video, or come in for help on Monday morning. Alright, I will be here. I want you to do well on this test. Let's dive right in. Show that the double argument property for sine of 2a works using a equals pi over 4. Alright, the double argument property. Remember, sine of 2a equals 2 sine a cosine a. You can derive that, but it's also right from your property list, so hopefully that shouldn't be too bad. So we're actually going to show that this works. So the sine of 2 times pi over 4, we're going to show that that's equal to 2 sine of pi over 4 cosine of pi over 4. Well, if you notice, 2 times pi over 4, that's pi over 2. 2 times the sine of pi over 4 is radical 2 over 2. And the cosine of pi over 4 is also radical 2 over 2. Sine of pi over 2, if you go to your chart, sine of pi over 2 is 1. So that means this whole thing had better multiply to 1. I'm going to leave the 2 out here alone for a second. Radical 2 over 2 times radical 2 over 2 is 2 over 4. Or if you'd rather simplify that, it would be 1/2, correct? 2 over 4, which would be 1/2. And 2 times 1/2 is, in fact, 1. So it does check out. That's all you're doing on this, is just showing that it works. Number 14, if cosine of a equals 3 over 7 and a terminates in quadrant 4, find the exact values of sine 2a, cosine 2a, and tangent of 2a. Obviously, we don't really need to know what angle A is, but we do need to know what its sine, cosine, what those individual values are. It is in quadrant 4. They do tell us that, so that's nice. We don't have to figure it out. Cosine is 3 over 7. So if angle A is down here, the cosine would be 3 over 7, adjacent over hypotenuse. A quick Pythagorean theorem tells you the missing side length would be 49 minus 9, which would be radical 40, which reduces to, or simplifies to 2 radical 10. And then this would be negative because it's below the x-axis. So we can actually do this now. Sine of 2a, again, is 2 sine of a cosine a. So I just need to know what the sine of a and the cosine a is. Well, sine of a is negative 2 radical 10 over 7. Cosine of a they gave us is 3 over 7. So if I take 2 times negative 2 radical 10 over 7 times 3 over 7, I get negative 12 radical 10 over 49. And I don't believe anything reduces. So that's the sine of 2a. Third of the way done. Negative 12 radical 10 over 49. Cosine of 2a, you actually have a couple of choices here. Because cosine of 2a actually equals 3 different things, right? Since they already gave us cosine, and I don't want to introduce any more of this weird, wacky negative 2 radical 10, I am going to use one that's strictly in terms of cosine. And that would be 2 cosine squared a minus 1. Alright, so let's use that. Well, the cosine of a is 3 over 7. That'll be squared minus 1. So we have 2 times 9 over 49 minus 1. And this is actually 18 over 49. Minus 1, I'm going to go ahead and make it 49 over 49. Just go ahead and get my common denominators there. And we have 18 minus 49, which is negative 31 over 49, and that's the cosine of 2a. Negative 31 over 49. Now, how do I get the tangent of 2a? Well, there is a formula for it. There's actually a couple. But if you do that, you end up with some wacky stuff. Remember that tangent of 2a is the same as sine of 2a divided by cosine of 2a. So you might as well use the answers you already have. Negative 12 radical 10 over 49 divided by negative 31 over 49. keep flip change, keep the first fraction, flip the second, 49 over negative 31, and change it to multiplication. One will notice that these negatives drop out, and the 49s drop out as well. Nothing else really reduces. You're left with 12 radical 10 over 31. That is the tangent of 2a. Much simpler than if we try to use the formulas. If you already have sine of 2a and cosine of 2a, just go ahead and figure out what tangent of 2a is from those. If they strictly ask for tangent of 2a, I would do the formula, but in that particular instance, that was easier. Number 15, solve over the interval 0 to 2 pi. Again, remember you might have seen it like this with the brackets. Okay, just don't get confused. 8 sine x cosine x equals 2. Remember, when you're solving these equations, you need to put them somehow into terms of one trig function, or maybe get something so that something will factor, right? I see this 8 sine x cosine x, and I'm automatically drawn to my properties. There's a 2 sine x cosine x, right? That would be sine of 2x. And that's perfect. That's what we want, because if I can get it in terms of just a single trig function, then we'll win the day, right? But unfortunately, it's 8. So what do? Well, I might as well divide by whatever it's going to take to get it to 2, which would be, in this case, 4. I'm dividing by 4. When I do that, I get 2 sine x cosine x, which is what I wanted, and that equals 2 over 4, which is 1/2. Now, 2 sine x cosine x is simply sine of 2x, and that equals 1/2. So, I can take the inverse sine, and I want to know, when is sine 1/2? And again, like I reiterated last video, you're going to get 2 possible solution sets here. Remember, we're in radians this time. So sine is 1/2 at pi over 6 plus some multiple of 2 pi. And the other one, remember how last time when it was in degrees it was 180 minus pi, or minus that one? Well, this time it'll be pi minus pi over 6, which is 5 pi over 6. And by the way, a quick scan of your table will reveal the 5 pi over 6, the sign is 1/2 as well. Okay, so your table can give you that second answer as well. Last thing you need to do is divide them by 2. Divide everything by 2. So you end up with 2 solution sets. We have pi over 12 plus pi in. And we also have 5 pi over 12 plus pi in. And we need values between 0 and 2 pi. Well, obviously, pi over 12 and 5 pi over 12 will work for those. But what about if I add pi to both of these? Obviously, I can't subtract pi, because pi in this case would be 12 pi over 12, correct? And I don't want to go outside of 24 pi over 12, because that would be 2 pi, right? So I need to add, and I do get 13 pi over 12, which is a good answer to go in that domain. And I also get 17 pi over 12. 17 pi over 12. Sorry, I shifted my answer over so that I could get the bracket in. But there are my 4 answers for that domain. Pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Obviously, I can't add or subtract any more 12 pi's over 12 because that would put me outside of my domain. 16. Confirm the following identities. I know there are still going to be a couple of identity questions on this part, so don't get too scared. Remember, identities, you're not actually solving anything. You're trying to get one side equal to the other side. So pick a side to start with. I think most of you would agree with me. Start with the left side. It's the more complicated side. I need to get it to secant A. And again, think about where you're headed. Secant A is 1 over cosine A, right? So somehow I probably need to get to 1 over cosine A by the end of the day in order for us to win. So sine of 2A, we have an A, we have a 2A, so I probably need to get all of this in terms of A's. So sine of 2A is simply 2 sine A cosine A, and we have over sine A. And this guy's cosine A. Now, cosine 2A, there are actually 3 different choices that we have for cosine of 2A. So the question is, which one do we use? Since we're trying to get something in terms of cosine, right, because secant's 1 over cosine, I'm thinking I'm probably going to use the one that is strictly cosine. So 2 cosine squared A minus 1. Alright, let's see what happens. Well, there's a couple things you could do here. you could notice that the sine a's over here cancel, and I'd be left with 2 cosine a over 1 minus all this stuff. And then I have two fractions, and I need common denominators, so I'm going to multiply here, the top and bottom, by cosine a. So when I do that, I end up with 2 cosine squared a over cosine a minus 2 cosine squared a minus 1 over cosine a. Again, this is all equals. When I do this, 2 cosine squared a minus 2 cosine squared a, this part right here adds to 0. The only other confusing part is you have a minus of a negative 1. Well, minus negative 1 would be positive 1. Make sure you're watching out for that. Again, that's just not a trig mistake, but that's a silly algebra mistake, right? Over, of course, the common denominator was cosine a. And hey, look, I'm not a liar. 1 over cosine a, which is where we were headed from the beginning, is in fact secant a. All right. Number 17, confirm that the half argument property for cosine of half x really works using x equals pi over 3. Again, we've already done a few of these, right? So, cosine of half x. Remember, this is the plus or minus radical 1/2 of 1 plus cosine x. Okay. The plus or minus, the sign is going to be determined by where the half angle lives. And if the angle's pi over 3, the half angle, or half arc in this case rather, is pi over 6. And pi over 6 is in quadrant 1. So cosine's positive. So we're going to be using the positive part of this. So we're going to be doing 1/2, 1 plus cosine x. Alright? Well, again, cosine of the half angle is just half of pi over 3, which would be pi over 6. And I'm going to start plugging stuff in. 1 plus cosine of x, so cosine of pi over 3, because that's what x is. Well, cosine of pi over 6 on your chart is radical 3 over 2, so I hope this side becomes radical 3 over 2. 1 plus cosine of pi over 3 is 1/2. And we end up with 1/2 times 1 plus 1/2 is 3/2. And you end up with the square root of 3/4. And by the way, remember when you take square root of a fraction, that's the square root of the top over the square root of the bottom, which is in fact radical 3 over 2. So radical 3 does come out to be radical 3. Radical 3 over 2 does come out to be radical 3 over 2. So we win. Alright, last question. This one's the big one. Over the interval 0 is less than or equal to theta is less than or equal to 360. Solve this guy. Alright? There's a couple ways you can do this. I'm going to show you one way. If you were ever in doubt, you could just square both sides, get rid of the square root, and do all that. But I'm going to show you. This looks an awful lot like cosine of half theta, right? But there's one little problem. Cosine of half theta has a plus or minus in front of it, and this doesn't. So if I'm going to make this substitution, I have to stick the plus or minus in there somewhere, and I'm going to put it in front of the 1/2, okay? You have to have that plus or minus in there, otherwise it's not a full substitution. Now, I'm in terms of single cosine, so I'm going to take the inverse cosine of both a positive 1/2 and of a negative 1/2. Alright? Well, where is cosine positive 1/2? It's positive 1/2 at plus or minus 60 degrees plus 360 in. And it's negative 1/2 at plus or minus 120 degrees plus 360 in. Multiply everything by 2 to get rid of that 1/2, and you get plus or minus 120 degrees plus 720 in. And you also get plus or minus 240 degrees plus 720 in. Alright? So the only answers that you're going to get between 0 and 360 are 120 degrees and 240 degrees. Even if you go the negative branches, negative 120 and negative 240, adding 720 is not going to put you between 0 and 360. So these are your only two answers. And if you were to check them, they both check out. Alright? The only trick with this one is make sure you have the plus or minus in there. If you don't, you only get half of your answer. Alright? As always, good luck studying. If you have any questions, please ask. Good luck.